and it should start working. And looks like it's all working. Oh. Keyboard matrix doesn't look right, does it? Alright. I'm typing numbers right now. I guess we gotta fix it. So, in the comments on the CoCo Nation, L. Curtis Boyle mentioned something about this. This is FlexOS from Stewart Orchard, and I had actually never heard about this before. So I wanted to go ahead and take a look. So this is on GitLab. And apparently he says it's an adaptation of the Flex operating system for Dragons with 64K of memory. Well, yeah, it also means that they can also work on CoCos as well. Okay, so he has some source code here, and it looks like this source code is, if we take a look at it, it looks like normal CoCo stuff, keyboard, a flex loader. It looks like this one uses the Becker port, so that's kind of interesting. If it uses the Becker port, that means that we can actually get it working with PyDriveWire, and also should be relatively easy. See, they have RS-DOS and Dragon, so it should be relatively easy to get it working with both of them. So I went ahead and downloaded this, and now let's take a little look at it. Okay, so here is the project, and it has a make file, and it requires a different assembler than a lot of us in the CoCo were used to. We're used to using LWASM for a lot of things, but this project actually uses AS6809. If we look at the make file, we can see that uses ASM6809. So if I make clean and then make it, it'll just build it. So what did it actually build? It built a few different things. It built this flex.sys, which is basically the core operating system plus the drivers. I have drivers.bin, which contains the disk driver, the keyboard driver, and the console driver. So that's what this thing contains. And there's also a loader program, which is called flexload.bin. I actually don't see that here. Yeah, there it is. Okay, flexload.bin. So we have a loader program, we have the actual operating system kernel, and there's a disk here, flex.disk. So it looks like this thing loads over DriveWire. So let's go ahead and take a look at that. Okay, so since we're using Becker port and we're going to be doing this with emulation, I just run PyDriveWire and tell it to listen on the standard port that the Becker port normally uses. And there we go. So the first time I tried this, I didn't really know what I needed to be doing. So I just went into it like so. I just ran XRoar with a Becker. And I want to tell it to use the loader file. XRoar can load binaries directly in. So if we tell it to load flexload.main, then this should start up and maybe do something. We'll see. Okay, so the first time I tried it, I didn't really know what I was doing. Tried to do a directory. Well, I didn't attach any disks to this thing. Wait a minute. It's supposed to be using DriveWire. And it loaded the binary somewhere. What happened with it? Exec? Whoops. Well, I don't know what that did. That clearly didn't do what it was supposed to do. Let's back up a moment and see if we can figure out how to get this loader to work. Okay, looks like there's a listing. Let's take a look at it. Okay, see, very important here. Org 4000. So that means that probably we want to exec 4000, see if it actually does something. All right. Don't want to save that. All right, I actually got what I needed to be doing. We need to say cart Becker so that it actually starts up with the Becker port attached. And if we do this, then we can actually see it says, doesn't say anything here on the screen. On this screen that we asked for the Becker port. But so if we go in here and actually look at our XRoar and look at the PyDriveWire window, we can see that it says that it actually got a connection. Okay, now let's see what it's actually trying to do if we try to exec this. Okay, we still get a DriveWire error, but if we actually look at the error, it's actually looking for, it's doing named object mount flex.sys. I know what I need to do with this. So the named object feature in PyDriveWire, you can specify a directory so it can look for files. So need a source in here. Okay, so that's the directory where the stuff is supposed to be. Let's see if we can get that running. Let's restart our XRoar. See if it gets any farther. No, still says it can't find it. Something's a little bit wrong here. So here is the source code for PyDriveWire in GitHub. And I'm on a branch that I just created called named object fix. Here's the change that I made to PyDriveWire, and there are 3 separate things going on. You guys saw before I had trouble typing the path name, so this first change actually fixes it so that it understands home like tilde, which represents the home directory. So that'll make the path names a little bit easier to type. So this is actually the main issue here. If you look at what this code is doing, I figured out that PyDriveWire was returning an invalid sized block to the CoCo. In DriveWire, when you're doing disk operations, the disk operations are always supposed to be sector size, and they're always supposed to be padded to the sector size. It turns out that that was not happening. So what this fix does is this fix basically ensures that every time the PyDriveWire server responds to a read request from the CoCo, it makes sure to pad it to sector size. It just pads it with zeros. So it's always sector size. So this was the main issue, that the flex.sys file is not a multiple of sector size, which is 256. And so it returned a short read, and that was the actual error. And the third thing that was going on was I had trouble finding the file, and it turns out that the sector command actually wasn't working. The server needed to change directories so it can find the file. So that's this fix. So now we can see what happens if I restart PyDriveWire with all of these fixes. Okay, so after making the fixes to PyDriveWire, I've restarted PyDriveWire, I've restarted XRoar. So now named object sector FlexOS fork. That should be correct. Okay, so I have the disk that was created in the project. Very simple flex boot disk. It's not really, in this case, it's not really a boot disk, but a flex operating system disk. And now, supposedly, when the Dragon tries to get the operating system file, it should actually look for it in this directory. So let's try this one more time. And you should see everything that's going on. So here we go. You can see in the DriveWire window in the corner, the very last line over here, it has a P on the end. So this was the code that was just added that actually pads the output so that it's a full sector size. And that made this thing work. All right, let's get our date wrong. Today is the 22nd. And there we have it. This thing is actually pretty fast. It's more than pretty fast, actually. Do we have any text files that we can look at? Specified file could not be found. Okay. Do we have build? Okay. That's pretty nice. How do we get out of this? I think we can type a pound symbol, list test.txt. Yeah, it's fast. Let's try something else. Let's try to redirect the output of cat. See if we have the O command. We do. Yeah, it's working. As you can see, this thing is actually pretty fast. Delete cat.txt. Yeah, sure. So, oh, so yeah, this is Stewart Orchard's FlexOS running in XRoar. The next thing that I want to show is I actually made the necessary changes to get this working on CoCo Emulation. So I'm going to show those changes next. I made a fork of Stewart Orchard's project, and that way I can make my own changes to it, and I can send him a pull request with my changes when I think they're actually all finished. So if you look at my fork here, I have a branch called CoCo Backer, and it has one commit, and that one commit changes to build the CoCo version. So I'm going to very quickly show the changes. I did a bunch of stuff in the make file so that you can basically type make CoCo equals 1 to build the CoCo version, and it sets some assembler options and things. The other thing that it does is MAME does actually have a loader system that's similar to what XRoar has, but it's not actually as convenient to use. XRoar is designed to use with CoCos and Dragons. It can directly load a bin file straight into the emulator. MAME can't. You have to use a raw binary that's not in the bin file package. So it's a little less convenient. Using a disk image is a little bit more convenient. So I added the ability so that when you say make CoCo equals 1, it actually makes this disk image as well when you run the make CoCo equals 1. Okay, so that's all the makefile stuff. You can force it to build the CoCo version if you set CoCo equals 1 here. First change here that's different in between CoCo and Dragon is the Becker port is at a different address on the CoCo than the Dragon. So this just says if it's the CoCo one, it uses the RSDOS one. And if you see, before it was just commented and it only had the Dragon DOS one. So now it's a conditional assembly. The only other change that was really required is to change the keyboard matrix, because the keyboard matrix is different on CoCo and Dragon. So let me explain what this change is doing first, and then we can come back to the code. Okay, so I found this page searching around on the net a little bit, CoCo and Dragon keyboard matrix, and it pretty clearly describes the difference in between the two. So you can see CoCo, they have the pins numbered 1 through 16, and if you see here, pins 6 and 7 are moved on the Dragon, and that's pretty much it. So you have 6, 7, 1, 2, 3, 4, 5, and 8, 9, and the rest of the pins are all the same. So this is the difference in the physical wiring. If you look at how the keyboard matrix actually looks, it's pretty clear to see what's going on with it. So this top one here is CoCo, and the bottom one is the Dragon. Let me make this a tiny bit smaller so we can see the whole thing on one screen, then it will make more sense. Alright, so basically there's two rows which are in a different order in the Dragon. So if we look at the Dragon one, we see that this row starting with 0 and this row starting with 8 are at the very beginning. But on the CoCo, it's these two rows. The keys in these rows are exactly the same. They're just in a different position. So the easy way to do this, if you're inside of a program, is you can use conditional assembly to make that happen. And that's exactly what I did. If I click on the right window here. Okay, so if you see all this, if CoCo, otherwise do this. So what we just saw was the CoCo one actually starts with @A blah blah blah, right? Here's the CoCo one. It starts with @A, right? So if it's the CoCo one, you want it to start here. But if it's not the CoCo one, in other words, if it's the Dragon one, you want it to start with the 0 row, right? Because the Dragon one starts with the 0 row and has the 8 row. But those are in a different place in the CoCo, so etc. This is basically how I made it conditional, and only I could have done this a little bit better. I could probably have used some kind of like macro thing so that I don't have to repeat the code, but this should be clear enough. If you're a Dragon and you're not a CoCo, then you want to have these rows start, and if you're a CoCo, then you want to have the rows here, etc. So I just went through the entire keyboard matrix and made all those changes. So this, in theory, should make the keyboard work for CoCo. So now let's rebuild the project and build it in the CoCo mode. Now I have the project open. All that we do is we do make clean to clean everything out. And then we run the makefile again. We say CoCo equals 1. And if we do this, we notice that it actually adds some stuff. D CoCo equals 1, D CoCo equals 1. There's a couple other changes. And the last thing that it does is it actually makes the disk for us. So yeah, there's our bin file on the disk that makes it more convenient to use with MAME. So let's go ahead and prepare for this. So what I want to run here is MAME window CoCo2B, and we want to attach this disk to it. flexload.disk, and that should be it. So I have my MAME running, I have my PyDrive wire running, everything is connected, but let's just double check before we continue. Make sure that our Becker port is on. It is. So I think we're good. I have attached the disk to this. Just show that. Yeah, floppy one has flexload.disk, the disk that was created from the makefile. So if everything works properly, okay, that should be fine. And I type execute, it should start booting up Flex. And there it is. Yes, it is. Okay. And pretty much the same as before. Well, let's just make sure the keyboard is working. All of the keys. Yep. All of the letter keys work. Yep. All the number keys work. These keys work. And how about shifted? Does shift 0 work? Is that caps lock? Ah, yeah, that works. For the most part, I think this thing is working. Pretty much the same as the Dragon version. So there you are. Have FlexOS working on both Dragon and CoCo emulation. The last thing I'm going to show is I'm going to show this running on a CoCo 3 FPGA. So on some physical hardware which actually has a Becker port. Now I'm going to demonstrate how we get this thing to run on a CoCo 3 FPGA. To get this thing working, we need exactly the same thing that we needed for MAME. We have a boot disk, which is called flexload.disk, and it has our flexload binary in it that we need to actually load the code. And the second thing that we actually needed is the actual kernel, which is flex.sys. And this kernel has all of the changes that we talked about before. Changes to the keyboard and the changes to the Becker port. So with these pieces in place, now we can actually start up PyDriveWire and then get this thing working. Okay, so I'm in my PyDriveWire directory and I want to get that started. We're going to use a serial port. So we say port, and it's called dev tty USB serial 420. And we're only going to be using 115.200. So we can start this up. Okay. And now we need to do a little bit of configuration. There are not any disks attached to this. So I'm going to attach to disk 1 the flexload disk, DW disk insert 1, flexOS, flexload.disk, and I'm going to insert a flex system disk into drive 0, and that's Flex 292 HD. Okay. So I have my Flex system disk, which has this particular disk has a whole bunch of different programs on it. I have my loader disk in drive 1. And there's one more thing that we need to do. We again need to set up the named object so that it can find flex.sys. So named object getter. Okay, so we just need to change this directory. So when the CoCo 3 FPGA runs the loader code, it can actually find flex.sys. Named object set.dir. And that's in the same directory, flexOS. So now at this point, we have all of the setup cracked so that we can start up the CoCo 3 FPGA and boot this thing up. I'm just going to set debug to 1 so that we can actually see what's going on. So my CoCo 3 FPGA is powered off at the moment. I am going to go ahead and turn it on. And there it is. So now we put the loader disk into drive 1. We should be able to see that here. There it is. We just load this loader disk up. Says something's wrong. Oh, I know what I did wrong. We need to tell it to load from drive 1. That's a little better. Now, just like before, when we type exec, it's going to go out to the DriveWire server. It's going to load flex.sys and boom, it's so fast. All right, get the date wrong again. And yeah, this disk has some weird settings on it. Let's set the working drive to 0. So when we type cat, we can see, yeah, it's, I'm not sure what key to press here. Okay. So we'll try like this. If there's no screen depth, it'll just keep going. Yeah, this is a huge disk. Has a lot of stuff on it, and it just zipped right through it. List. These are C defines or flex. It's just listing that thing like crazy. So fast. Yeah, this is the demonstration of running it on a CoCo 3 FPGA. Alright everybody, this sums up my coverage of FlexOS from Stewart Orchard and how I got it working on both CoCo and Dragon. So I hope you enjoyed this episode. Bye for now.